Hello everyone, and thank you for attending this talk. It's our pleasure to present to you our work, which is a personalized menu in your contextual collaborative recommender system. This work has been realized by Dr. Zitouni, Miss Bouchelik, Miss Saidi, and Dr. Chekkai. In this presentation, we will start with introducing the context of our work. Then we will take a look on the field of contextual collaborative recommender system. After that, we will present the related work. Later, we will present in detail our proposal. Then, we will present our prototype and our obtained experimental results. We conclude this presentation by summarizing the presented work and giving some of our future plans. Well, in our days, some diseases like hypertension and diabetes and even cancer have been increasing, and diet is one main solution for these health issues. Indeed, going to restaurants or eating outside home is a daily lifestyle of many people. Thus, the variety of proposed food and the combination of the ingredients present a recent important challenge. So, according to the studies of Free University of Pose and Bolzano at Italy, done on a sample of people where 65% of them are men and 35% of them are women, about the following question. So the question is, would you like to have healthier food recommendations by adapting or giving into your recommendations your personal taste? So the results have shown that 95% of these people like to adapt and personalize the menu recommendation according to their tastes and also according to their healthy state and their preferences. For that, we propose a new recommender system that generates personalized menu for users while taking into account the following constraints. So first of all, we take into account the general information about the user, the gender of our user, his age, his weight. We also take into account the healthy state of our user, if he suffers, for example, from diseases or not. We also take into consideration the physical activity of the user, for example, if he practices sports or not. We also note his eating habits, if he eats halal, for example, if he is vegetarian, and other habits. We also take into account the food preferences of our user and additionally his contextual information such as the time and the temperature. We now take a look on the field of contextual collaborative recommender system. So, in personalized recommendation field, we find three types of recommendations: the content-based recommendation, user-based recommendation, and the hybrid recommendation. Each of them is based on a specific type of filtering. So content-based recommendation is based on content-based filtering. Users' recommendations uses collaborative filtering, and hybrid recommendation uses hybrid filtering. So, content-based recommendation is based on the content process, which generates recommendations based on the user query. Collaborative filtering process proposed to the user items that have been well rated by other similar users who have, for example, similar profiles, while a hybrid recommendation combines the two filtering types. So, collaborative filtering is based on what other users have already seen and rated using explicit or implicit votes. However, collaborative filtering is facing one known challenge, which is the cold start of new user or new item. In cold start user problem, here the system generates propositions for his users who have no ratings yet in difficult situation, as the profiles of users are empty. Another important problem is the cold start item, when a new item enters the system and cannot be suggested since it has no ratings yet. These are some of related applications about healthy food recommendations. These systems consider the healthy factor as just a feature and not a main priority. So we find, for example, Bouchelik, Amazon, Yumi, LifeSum, Shopwell. So we observe that the context of the recommendation differs from the system, one system to another according to the intended purpose. Most of the proposed systems consider the health factor as just a simple attribute and not a priority parameter. No one of the studied systems considers the user preferences and the food healthiness and the user environment all together to compute the recommendations for the users. We now propose our new idea. So, our proposal is based on the following features. First of all, the user. In our system, a user is a person looking for a help tool to choose a healthy meal and satisfy his taste at the same time. An item is represented by a meal. The evaluation or the rating is a measure of satisfaction attributed by the user for a recommended item. The community is a set of users who have the same taste based on the history of their ratings they assign to the same recommended item. A stakeholder is a set of users who process the same personal features. The aggregation is a set of items that are relevant to all users of a specific stakeholder. And finally, the context is the external user environment. We now present our architecture. We propose a new approach that consists of 3 layers, namely the healthy layer, the tasty layer, and the pertinent layer. The healthy layer is based on the pre-filtering process. The tasty layer adapts the collaborative filtering process, and the pertinent layer is based on the post-filtering process. We start with the pre-filtering process. So, in healthy layer, the pre-filtering process is used. It's based on the healthy state and physical activity of the user. Each user is classified in a stakeholder according to his demographic information at this certain stage of our system. Then the nutrition and the contextual information are adapted as shown in this equation that calculates the prediction for a user about an item. We now present our second layer, which is the tasty layer. So, tasty layer is based on the collaborative filtering. So the users are grouped in communities according to their ratings on items that represent their preferences and their tastes. Similarities between users are computed using cousin similarity. And finally, we present our third layer, which is the pertinent layer. In this last layer, the post-filtering is adapted based on the temperature and the time factors, which are contextual information of the user. The items are classified according to their features, and then the prediction is computed using this third formula, which compute the prediction of an item for a user. Here we see the global recommendation process of our proposal. So the global prediction is computed using the prediction of each of our three layers using the following proposed global equation, which takes into account the first prediction of the first layer, the second prediction of the second layer, and the third prediction. And here we see our global architecture, which illustrates that we generate personalized recommendations of our users. So our new user is oriented to an initial stakeholder using his profile information. Then the aggregation of items is adapted. On the other hand, the system collects the contextual information about the user. Later, the predictions are computed. Finally, our system will be able to generate relevant recommendation of the key top items. We now present our prototype and the obtained experimental results. So these are some examples of our application, which is named Healthy and Tasty HNT system. So we have tested our approach on our own proposed dataset that includes 524 volunteer users who rated more than 83 items. We have used the mean absolute error and the root mean square error in order to estimate the performance of our proposed approach. These are our obtained results. To conclude, we presented a new recommendation approach named HNT, Healthy and Tasty Recommender System, by describing its main principles based on the new concepts, namely the aggregation and stakeholder, that aim to solve the problem of cold start. We detailed the HNT architecture and the recommendation engine process. We have presented the prototype of our proposal and also our experimental results, which were very promising. As future work, we planify using the web of data to attach semantics to our users' tastes and create a comprehensive corpus for large-scale validation of the system to be used as a benchmark in future studies. Deep learning is also an interesting perspective of our work. Thank you. Your questions and your recommendations are welcome.